It's Roger once again, Mudfossil University, and you say, what are you doing talking to me about playing with a tractor beam magnet? Now, this is from Latham's Crazy Machines. I'm going to narrate this. I will be the narrator. That is a brass ring with 6 neodymium magnets. Boom. This is a positive attractive source put in the middle of that negative source, creating the core of an atom. And now we have just seen the electron approach the core and is held at a quantum distance. You say, why? Well, it's because the negatives attract to the positive until they exceed the positiveness just a hair, so that no more negatives can come in here. They're held away because the negative pushes them away, because they surround the positive core. Now, the positive core, however, has an enormous attractive value. Even though you don't see it, even though it overrides the negativeness, we can obviously see it's trying to attract this negative. These are trying to keep it away. So we got a little fight going on. All right? Now watch what happens. That electron in its orbit can shake and create heat, and then it can fly away and be light, or it can be invaded and pushed away and be electricity. And if there was so many of them that there was a batch of extra ones, which there are, called aether, they will collect on people as static electricity. And you will discharge them to ground when you touch a water pipe. It's as simple as that. You're not sending off chunks of matter. You are sending away electrons, which are the extra electrons that collect on you. I've shown these in experiments. So this is the quantum effect, and let's watch heat and light. That's just normal, laying around, not doing much, maybe a little noise, a little vibration here and there. And then all of a sudden it starts getting a lot of friction, scrubbing, rubbing, throwing, electricity bouncing in there, light crashing through here. Whatever it is, it's a vibration, heavy vibration, smacking it, hitting it with a hammer, whatever you're doing. It's trying to force that electron off its orbital, and it's heat, and it's getting hotter and hotter and hotter. And when it takes off, it becomes light. It says, I want to stay here. Nope, you're going. That's when it becomes light. That's escape velocity, basically. It obviously leads to a new atomic model where electrons are light particles, and I will show that. Light is a dipole. It has a positive and a negative in light itself. I will show that. Light can be accelerated. I will show that. Light can create Higgs bosons and be even divided among itself. It can actually be divided. I will show that in our experiments. This is not a guess, not even close to a guess. These are 100% experimental evidence. Now, beyond that, these are my speculations. I say the core, which is the nucleus, is literally flooded with electrons, as you just saw in Latham's crazy toy, and there is no neutrons there. So whatever the neutrons were, replace them by electrons, and that's your core. And the electrons flood the core, and neutrons are bigger than protons, so they always have an excess mass of neutrons, which are really negative particles, negative mass particles. So you will always have a little excess negativeness in the core, which will keep your electrons coming in at a distance. Now, neutron mass is nothing more than electron dipole mass. Right? So every neutron is nothing more than a little bar magnet. It's a little bar magnet inside there. Not neutrons of nothing just floating around being like bowling balls that have no effect. Now, hydrogen cannot be a proton and a neutron. That would never work. Hydrogen is at least half of it is a proton. The other half is an electron plus a little extra, which keeps the electron in its resonance frequency, which I believe is about 345 hertz. And that's the distance away from the nucleus that electron resides. And that is a tight pull. So that's extremely powerful hydrogen. Now, I also believe there's 9 species of electrons. Now, they really disregard electrons. They say they only weigh 0.00055 atomic mass units, and they really don't even hardly count them. So I say there's 9 species of them, and they're all pretty close in weight, but they have certain weights, and there's 9 of them. One of them is in the s orbitals, and the other 8 make up the rule of 8. And that makes, and they're all different weights, which give them different resonance frequencies because they're different distances from the nucleus. And that creates the Fraunhofer lines. There's 9 heavy Fraunhofer lines. I'm going to show you all of this in experimental, evidential, vibrating, resonating truth. All right, very, very little speculation here. There is some, yes, but this is not speculation. Let's talk about that. That there is no neutrons, and when you take neutrons out of the equation, everything turns correct. Everything, including gravity, anti-gravity, electricity, static, the Fraunhofer lines, lightning, ball lightning, electric discharge of every single nature is perfectly understood if you take electrons out of the mix. And what if you take neutrons out of the mix? If you take neutrons out of the mix, what do you end up with? Where there was a neutron, there is now a bar magnet. A neutron is nothing more than a plus and a minus together, and it ends up being a particle just like that has positive and negative together with it. And as you can see right there, that is what we're talking about. Now, that is also an electron. That is light. That is from a light red laser. That's the red laser. That's through the Venturi, accelerates the light, so it does accelerate. It shows that it is particles, and they are easily seen as particles. And I'm going to be going through all of this. Then when they come out the other side, they are the bosons, charged particle carriers spinning, creating a field effect around them when they slam into the unaccelerated space. And then we actually found a new particle that nobody knows about yet, where one of these particles came out of here spinning extremely white and bright, which was a left-hand spin instead of the right-hand rule. And that particle is that white particle slammed into one of these fields and created whatever that is. This is the right-hand rule of the spin of the particle, which means it will drift left. That is the boson portion. Let's go into the experiments and the truth about neutrons, which is they do not exist. And I will show this in great detail. And I'm looking for somebody to challenge this. So please challenge it. But don't just say that this is crazy. Tell me why it's crazy. And explain to me the time on the video where it was crazy and what the error is. And I know all the theories that you have about neutrons, and I don't know how you came up with them, but I know the theories, and they don't work. This does. It's called electron flood. Everything is flooded with electrons. And I believe a neutron star is nothing more than a star or a body that has collected so many electrons that it becomes unstable, and when it gives off its energy, it's raw energy, electron energy. That's what a neutron star is. That's why it's so violent. On a neutron exploding star, you first get the electrons, then you get the bar magnet particles, which are the heavy particles, including the protons. They will look similar to the light, but light just is a very, very small particle compared to what they would have called neutrons, and I call, well, I don't know what to call them, to be perfectly honest with you, but they're bar magnets, really. So they're not neutrons, but they're tiny particles of atoms. They are not resonance stable particles. So they come out in chunks, flying extremely fast. They are much, much, much heavier. Hundreds and, well, thousands of times heavier than individual light particles, which are the first, as you see the flash from an atomic bomb, and then after that, the bar magnets come out. And those are what they always thought was neutrons. So let's go into the experimental evidence and the absolute, I think it's absolute proof that shows what I'm saying. And I want to have somebody challenge you. I really do. All right, everybody knows what an atom is supposed to be. Electrons, which are supposed to be negative. Protons in the core, which are supposed to be positive. Nucleus, neutrons, which are just have no charge at all, they say. And that is your nucleus, the little core in the center. The electrons, the negative particles, spin around out in the out area. They have regions, they claim. Now, let's look at what I have discovered in some experiments. All right, this is true experimental results. Now, Rod Warren in Australia was doing some just really experimenting, playing around with light. And he came up with a Venturi accelerator. Just an accident. And when I saw what he was coming up with, I got a hold of him, and then we finally determined that it was this acceleration device that he was using. It was strictly 2 metal pins. And when you send the wave through and it crashes through the metal pins, it gets excited and it displays its true characteristics. And here's the Venturi acceleration. Now, here you have 2 round metal pins. They were literally nails. The beam of light approaches that restriction 2 airplane wings. It's called a Venturi. Fully understood, it makes things atomize. Liquids, it makes atomize. And what are liquids? Liquids are particles that are in solution. All right? These are particles in solution. That's all it is. These are particles in a solution. These are the particles. They are forcing their way through this solution, creating this huge anomaly in the solution. And then, because it is being pulled through the Venturi, it elongates the wave, showing that light can accelerate. It now displays the particles in this beam, because those particles are now invading each other's regions. It's like water crushing into each other. Now, water is not compressible, so it would just crush and heat, and that is what's basically happening here. That is heat and light and energy increasing. Now, why is it increasing? It's increasing because it's crushing. Energy is nothing more than a display of force. It's a display of crushing. It's a display of invasion. It is a display of bombardment. That's all energy is. And if you can hit something hard enough, you will drive those particles away from it into light, electricity, lightning, electromagnetic radiation. Do you see this electromagnetic radiation? Do you see that wave coming back there? This is a reverse wave. And why is it reverse? It's reverse because when it hits here, it blows up like a bomb. Boom, 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 and it's sending them back this way. When they come back, what do? They accelerate the medium that is the ocean of space, which is our atmosphere, and all of these little tiny white particles are the ether. That is ether. Now, ether is the extra electrons that are in the air. And you say, oh, electrons, they're negative. Well, they do appear to have a negative propensity, slightly above their positive propensity. So they appear to be net negative, but they are dipoles, and I will show that and prove that. By the way, before we do that, I want to explain, these are the interference patterns, they call them. And they are from waves. They thought they were like waves of water swishing down, and then they would radiate away and overlap each other and interfere with each other. But that is not the case. The case is that the particles themselves become plasma here, which means that they are all literally touching each other, and that is not allowed in their realm. They own a bubble around themselves. The particle is unseen. The bubble is literally huge. I mean, it's literally huge. And when you force them to invade each other's regions, that's what causes glowing. Because every time it smashes into anything, it's invading another electron. Everything is coated with electrons. There is nothing that has a surface that is positive. Nothing. The only positive surface that ever presents itself is after a nuclear bomb explodes. And all the light particles leave, the negative particles, the little tiny dipoles, which I'll show you in a moment. What you end up with is a core that is essentially positive, and it wants to recapture the negatives. That's why it's thrown away from the Earth, straight up in the air, and it pulls the mushroom cloud into itself to pull the electrons back in. That is that's electron flood, it's called. And it means that there's no neutrons in the cores of any matter whatsoever. There is no neutrons. Those neutrons are essentially bar magnets. And we're going to take a look at them right now. That is the particle. That is light. I'll show you how I can make that statement in a moment. You obviously see light and you see dark. And then you see a spike here and a spike here. I feel, well, it's certainly a dipole. There is no question that anybody could present, there's no argument you could present that could say that this is not a positive and a negative particle. It has both of everything, and it is a bar magnet here. This is let's say this is the positive, this is the negative, because I go with negative being the power source. And this is a negative, this is a positive, positive, negative, negative, positive, positive, negative. It's a bar magnet around a circle. And I feel that the flow of the negative charged particles, when you bash into this, you get plus minus, plus minus, plus minus, and then it wraps and it spins down into the torus, and with a right-hand rule, and it comes back with a right-hand rule, but it spikes back, creating a darkness region. So it's dark, light, spins down and spins back out. Light, dark, light, dark, light, dark, in through this venturi. That's my claim. That's my statement. Now, the reason that you're seeing this and the reason that was propagated, I'm going to show you the red ones first. You saw the accelerator, and in this case, that is the final exit from the accelerator. It does a little blurry thing, and then it gives you these particles twice. And then it goes back into a blurry thing. Now, the green does the same thing, only it happens in a much further distance from the accelerator because there are heavier particles. Now you say, oh, heavier particles. I thought electrons were all the same. I don't think they are. I don't think they are the same at all. I think there's heavier ones and there's lighter ones. And the reason these don't crash until they're further away is because they're heavier. And the blue ones are even heavier than that. I believe there's 9 different species of electrons. Now I'll show you why I believe that. The reason I determined there's 9 different species of electrons is because these are the dark lines here, A, B, C, D, E, F, G, H, K, okay? So there's 9 of these. Way down here is your hydrogen, the heavy, real close to the core, very close, short frequency. Very short frequency from the core, and then you go further and further and further out, and way out into your red is your furthest ones away from the core, and they are the least held to the core, so they have the least energy compared to this because they are held very tightly to the core. Now, why do I say there's these 9 frequencies? What else can I back that up with? Well, let's take a look at another experiment. There's called a rule of 8, the octet rule, which means that all atoms that are stable, like noble gases and so forth, are stable. They have 8 electrons in their outer orbits. in their valence shells. Now, what is that? How can we prove this? How can we talk about this in an experimental way? Well, let's see. Okay, Nikola Tesla said, if you want to find the secrets of the universe in terms of energy, frequency, and vibration, energy is nothing more than impact. It's nothing more than collision. Frequency is nothing more than the distance of the wave. Vibration is nothing more than shaking things. He was 100% right. And as always, demeaned. All right, now let's watch this. This is from Bruspup. It's Amazing Resonance Experiment. Very nice. Now, I'm going to explain to you as this goes through. There are frequency, resonance frequency means something that's stable. Now, you have an s orbital which is really close to the helium atom, and it only has 2 electrons in the very tight orbit. That's the real blue one. Now, here's what happens. He's going to go to 345. See, at 345, this will lock in. That's your core. This region is where your s orbital can be. You could have an electron anywhere in here, or you could have 2. Okay? That's the s orbital. Now, after you go from here, you go into the rule of 8. So there's 1, and then we got 8 more to go. All right, so it locks in. Look how perfect that is. But in between these frequencies, it shakes all over. It cannot stabilize. It cannot turn resonance. At 1033, we go into the rule of 8. See 6, 8 all around the core now? And it stays stable right up, and you have 8 all the time. 8, 8, 8, 8, 8. Okay, you'll find 8 around the core if you look around. This one is not as easy to see as the rest, but you can easily find it if you look. But then you look around here and you've got 8, 8, 8, 8, 8 going out of your ears until you hit, I believe it's 4129, and then they start to fall apart. There's your 8 again. All right. There's your 8 again. Very elegant patterns until you hit a certain frequency, and then they just can't maintain that rule of 8 anymore. All right, so 3975. Then we're going to go to 4049. Watch what happens. At 4049, it stabilizes. There's your rule of 8, absolutely flawless. Then you go to the last one, 4129. Watch what happens. 4129, it stabilizes, and then it falls instantly apart. Let's come back, because this is the last one of the Fraunhofer lines. You see it? 4129, perfect. 3, 3, that's 6, 2 is 8. Everything's good, but still at 4129, if it hits 4130, 4140, it falls apart. Watch. You see? It just fell apart. It fell apart. Look what it's got. Now the next ones fall apart just regularly. They don't have any consistent rule of 8 anymore. That's why, see, look, they're all floppy looking after that. You know, I think there may be 1 or 2 that look pretty consistent with a rule of 8, but, and they may be a very, very stable, high up energy that it, you know, and that one might be stable. When you see a nice consistent pattern, then you can maybe make it out for a semi-stable. But these, in my mind, these are the above the 4129, you end up with molecules. By that I mean that they are more than one different molecule. So in other words, even though we have the core here, there would be something out here trying to attach to that, and it's looking to try to find those attachments. And they're just sort of falling apart in between all these areas. There's not a whole lot of really very powerful, consistent forms. I mean, look, they're all shaky and wobbly and not structurally significant like the rule of 8 frequencies. And I say the only reason that each one of those had that frequency resonance stability was because it weighs a different weight than the other one. It's as simple as that. You have 9 different weights, and that determines how far away it will shake and be structurally sound. If it's lighter, it won't stay there. It will stay only up here. It will shake right. If it's real heavy, it will be out here and maybe shake correctly. Either one way or the other. So there's a lot to look at in this to understand. But I'm following this through to figure out that the atomic model is just doesn't work. There are no neutrons. The neutrons are nothing more than bar magnets. They're bar magnets. And when you explode an atomic bomb and they break up those rule of 8 molecules and atoms, and they blow them into little bits and pieces, you got bar magnets flying all over the place. They thought were neutrons. They're not neutrons. They're heavy particles, but they are bar magnets. We've seen that even an electron, which I call light as electrons. I don't think there's any such thing as a photon. A photon is an electron. That's all it is. And when they come from the sun, they go through the air, through the space of the vacuum of space, which is not a vacuum, it's loaded with light. The light comes from the sun. It got to get the air from the sun. I mean, it's insane to think it just appears here with nothing between. I mean, really, we say, just give it a little thought, for goodness sakes. All right, well, anyway, that's, and this guy here, I'm sick of him. Neil Tyson, tired of God? Well, I tell you what, Mr. Tyson, we're tired of you, my friend, because God is tired of you. By the way, Mudfossil University, we love God and Jesus and the prophets and Mohammed and all of them, so you better get used to it.